Hello there and welcome to our second video in our data security chapter. In this video we're going to look at biometrics. So what are biometrics? They are biological measurements or physical characteristics that can be used to identify individuals. Biological authentication is used in computer science as a form of identification and access control. It could be access to banks with safes, it could be access to your building, for example, or secure server rooms. It's also used to identify individuals in groups that are under surveillance. So we need to look at different types of physiological metrics which can be measured in computer science. And the first one we're looking at is facial recognition. And a facial recognition system is a technology capable of identifying or verifying a person from a digital image or a video frame from a video source. And facial recognition is a real growing technology, and it works on measuring how far apart your eyes, your jaw, your nose and cheekbones are relative to each other. But one of the key issues with facial recognition is when the image is captured for comparison, it must be done under good conditions, like the person's face being clearly visible, for example, or the light conditions need to also be quite good. Although some systems can work by building a 3D model of the face, it's much more accurate when facing straight on. And this is why photographs of passports ask you to look straight on into the camera. And that's all for facial recognition when you go to an airport, for example. We've seen recent developments in facial recognition and the accuracy of it with things like the iPhone 11, for example. And the reason why it's nice and quick is because people's faces don't tend to change and it's quite a secure method. The next one we're going to look at is all about fingerprints. And fingerprint recognition uses fingerprints, obviously. Fingerprints are an impression left by friction ridges on a human finger. These friction ridges are unique, and fingerprint scanners are mostly seen in smartphones now. The scanner is usually built into a capacitive screen. In a similar way, it will record the touches just like when you're touching or making gestures on your phone. The patterns of your fingerprint actually make up a number of ridges and valleys. So when you press your finger on your screen, not every part of your finger will actually touch. This is picked up as variations on the screen, and it's converted into a pattern. And this modern form of fingerprint scanner that we use in our screens cannot be fooled by a printout of someone's finger, as it does not work by taking a picture. Usually when you're setting up your fingerprints on your phone, it'll take a number of different fingerprints from a number of different angles, and this is all to ensure accuracy. And as good as these biometric methods are, you can actually combine them to make them stronger. But obviously there is a cost there to people putting them in phones, for example, or to buy scanners and things like that. The next one we need to look at is iris recognition. And iris recognitions, it uses mathematical pattern recognition techniques on video images of one or both of the irises of an individual's eye. And again, just like fingerprints, these are unique. And these patterns are very complex. They are unique and they are stable. And believe it or not, they can actually be seen from some distance. However, the scanners tend to be quite expensive for these, so most developers tend to shy away from this. If we look at something like DNA, for example, the problem with this one is it takes a long time to get results back, but DNA is very accurate, and DNA recognition is an enormously useful biometric identifier in situations such as criminal investigations, but it has serious limitations for other purposes, such as establishing immediate authentication of a subject's identity. If you try to get into your phone and you use your DNA, that will take an awful long time for you to open your phone, so obviously that's not ideal. And finally, we look at palm prints. Our hands are very unique, our skin has lots of ridges, and that can be mapped. So palm print recognition is a biometric authentication method based on the unique patterns of various characteristics in the palms of people's hands. And again, scanners are used, and they're based on camera-based applications along with associated software that processes the image data of a photograph of an individual's palm, and it comprises it to a stored record of that person's palm print, and it works very similar to fingerprints. So for all the methods that we've seen so far, you already need in your database a bank of the person's biometrics. And this is used to compare the data we have to the data that's being collected through scanners and cameras. Now we move on to something you may have seen before. If you've ever used an airport or a passport before, then you have definitely had your biometrics taken for that process. Biometric passports use a combination of facial recognition, iris recognition, and fingerprints. UK passports contain an RFID chip, and that has your passport number, your name, and your date of birth on it. This is then linked to a database which contains your photo and biometric data, and the data comes from your photo directly in the airport, and it compares the two. And the system uses facial recognition and iris recognition using the data from that photo. If all is good, the doors open and you proceed ahead. And the job of these is to reduce the waiting time. However, the jury's out, I'm not so sure. Sometimes they do, sometimes they don't, and sometimes they're quite temperamental. What about this here? India's national ID program. Its name is Aadhaar. It's the largest biometric database in the world, and it stores biometric-based digital data for a person's lifetime. That means that people that have access to the database can verify someone's identity at any time from anywhere in a paperless way. It's designed to enable government agencies to deliver a retail public service that is secure based on biometric data such as your fingerprints, your iris scans, and your facial recognition. It also has other information there as well, such as demographic data, things like your name, your age, your gender and address, parents or spouse's name, mobile number. All that data is stored on your ID card, which refers to a digital database. And the data is transmitted in an encrypted form over the internet for authentication. It's hard to gauge the number of users of Aadhaar, but in 2013 it was reported that 550 million residents have been enrolled, and the government actually wants to cover the entire population of 1.2 billion people, all inside this system. That's a lot of capturing of biometric data. And there's been lots of concerns about the security of that data and who actually has access to it. And it's even been reported that people have been selling off data to third parties. Talking of selling off data to third parties, what about Facebook? You can't really go anywhere without Facebook being entangled in some sort of lawsuit regarding people's data. In 2019, Facebook lost its federal appeal over its attempt to own the public's facial recognition data. As a result, the firm is set to pay out a substantial amount of money for its ethical and business practices. It's also forced the company to halt its facial recognition photo tagging suggestion feature, and it's now offering it on a voluntary basis, but you need to opt in order to get that working. And remember, everything that goes online potentially risks someone else selling your data. So to summarise, biometrics have a number of advantages and disadvantages. To summarise, we need to look at biometrics as a whole. So we'll discuss the advantages and the disadvantages of biometrics. Biometrics are more secure. They're more secure than passwords, which can be guessed, because biometrics are your own data. Unless somebody replicates you by cloning you, they can't get access to your biometrics because you own it and you can't give it away. It's very difficult to replicate the data, like I said, without cloning somebody. And biometrics cannot be lost, stolen, or forgotten, and that's because they are based on your biology. And there's no chance of social engineering, where somebody befriends you in order to get your passwords and usernames out of you. There's no chance of you giving somebody your biometric data without chopping off your finger and giving it to them. And it speeds up conventional queuing systems, reducing the need for humans because they tend to be quite slow at processing data, and not to forget the number of mistakes humans can make. There are a couple of disadvantages also. Some biometrics are not always 100% accurate. Some biometrics even have a range of accuracy that is accepted or not accepted. You might have seen this on your phone when you try and use your face and it can't quite work out who you are, or it tries to use your fingerprint and it can't work out that it's yours, so then it'll ask for a passcode. People change over time as well. Things like aging and illness can change your physical appearance, and you can get involved in serious accidents and get serious injuries. For example, if you lost an arm, you couldn't use your fingerprint. And there are lots of privacy concerns over biometrics. It's a very, very powerful thing. Like we were discussing before with India and Aadhaar, people can sell on your biometric data to use for malicious reasons. Also, for example, you've got unfair use of data, e.g. using shopping activity. I know cameras in China can track who is going where, what times they're going and what activities that they're doing. And that's all based on biometrics. And is that ethical? Some people say yes it is, it's good to know the government, it's good for the government to know where you are, but others say no, it's actually unfair, there's a right to privacy. And for this chapter, there can really be a huge question on biometrics alone. There's lots of things to discuss, the positives and negatives of it, but that's everything that we need to cover for our A-level on this chapter. And do join me for the third video on contingency planning, malicious and accidental damage. And thanks again for watching.